Go recording. So we have a carton of eggs, and there are 12 eggs in the carton. They tell us the average amount of eggs in carton together weigh 840 grams, and the standard deviation of the carton and eggs together is 7.9 grams. And this says, what is the probability that randomly selected full carton of grade eggs will weigh more than 850 grams? So here's what we have. We have a mean of 840, and then we have 850 here, and we're looking for that probability. That's what we're looking for. And since they've told us already that they're normally distributed, I could draw the normal curve, and I use a z immediately. So I want the probability that x is greater than 150. 850. I plug in 850 for x, 840 for my mean, 7.9 for the standard deviation. Once again, I could use a second VARS normal CDF, but I'm going to use a stats test, z-test. And in this case, my mean is 840. My standard deviation is 7.9. The x is 850. We only have one carton, and I want to know the probability is greater than. So I end up getting 1.27, and that probability is 0.1028. So there's about a 10% chance that we get a carton of eggs that weigh more than 850 grams. All right. They tell us the weight of the empty cardboard container. So the container by itself has a mean weight of 20 grams and a standard deviation of 1.7 grams. It's reasonable to assume that the weights between the empty carton and containers and eggs are independent. It's also reasonable to assume independence among weights of the 12 eggs. We'll talk about why that's important in a little bit. So let the random variable x be the weight of a single selected grade egg. What's the mean of x? So what they're saying is they want you to find out, on average, what you would expect a single egg to weigh. Well, they tell me the whole amount of the box, and they tell me this in part up at the top in the very stem, that the total amount weighs 840. They tell me the box weighs 20, and I have 12 eggs. So egg 1 plus egg 2, etc. So 12x plus 20 is 840. I subtract and get 820. I divide by 12, and I found that on average, 68.33 is the average grams per egg. All right. So on average, I would expect a single egg to weigh about 68.33 grams. So the next part is the standard deviation. And this is where I had hoped that problem 3, part E, might help a little bit, refresh your brain, although truthfully, that was a more difficult problem than this one, but this is not straightforward either. First off, they tell us independence. Independence is really important to know because you cannot combine standard deviations if they're not independent. Now, you can combine means if they're not independent, but you cannot combine standard deviations. So we needed to know that they were independent. All right? So, and off to the side, I just made a little note. The box weighed 20. The standard deviation is 1.7, and I got that from over here. They told me the total carton had an average weight of 840, and the carton and eggs to combine had a standard deviation of 7.9. Again, I just made a note to myself. And they asked us for the egg mean weight, and we just calculated that. We said the egg mean weight was 68.33. Now they want to know what's the standard deviation of an egg. All right, well, that point, remember, we can't add standard deviations directly. We have to convert them to variances, sum them, then we take the square root to find the individual. Well, we know we have egg 1, egg 2, egg 3, and then we have the carton. So they've all been squared and converted to variances, and that's going to, and then we take the square root of that total, and that gives us the standard deviation, or that gives us the standard deviation that we had before, or that they gave us in part in the stem, of 7.9. So I have 12 eggs, and 1.7 squared is 2.89. I went ahead and squared everything. So the 7.9 squared is 62.41. I subtract the 2.89. I divide by 12, and I take the square root of that, and I end up getting 2.27 grams. So my standard deviation per egg is 2.27. Okay? And basically, you need to make sure that things are independent before you combine. You need to make sure that you convert them to variances before you sum them. Please remember, you can never subtract them, you can only sum. If they ask you to subtract, you are still going to sum the standard deviations, but you must convert them to variances first.